So here we shall explain the concept as how dy by dx can be explained as the rate of change of some quantities with some examples. So when we tell dy by dx, this implies the rate of change of y with respect to x. The rate of change of y with respect to x. So now, and when we tell dy by dx at x equal to x naught, or we can say it as f dash x naught, it means that when we tell y equals to f of x, and when we do dy by dx, then we can write it as d by dx of f of x, or we can write it as f dash x. And similarly, so dy by dx, when we tell at x equal to x naught, it means that we are finding the derivative of f of x at x equal to x naught. So we can call it as f dash x naught. So and also suppose we have x as a function of t, f of t, and y if we have as g of t, then if we have to find dy by dx, then we can write it as dy by dt divided by dx by dt, if this dx by dt is not equal to 0. So it means that when x is a function of t and y is some other function of t, then the rate of change of y with respect to x, that is the ratio of the rate of change of y with respect to t, and by the rate of change of x with respect to t. Okay. So for example, suppose if it is asked to find the rate of change, of the area of a circle per second with respect to its radius, when with respect to its radius r, when r equal to 5 centimeter. So we know that the area of a circle is pi r square. So here we have to find dA by dt, means the rate of change of area with respect to t, which is time, t for time. So we have to find rate of change of area A with respect to t, where t is time. So dA by dt we have to find when r will be equal to 5 centimeter. So that will be equal to d by dt of pi r square. So that will be 2 pi r into dr by dt. So when r is 5 centimeter, it has been told. So here we have to find the rate of change of area with respect to its radius. So we have to find dA by dr, sorry. So it means we have to find only 2 pi r. d by dr of pi r square, so which is 2 pi r. So it will be 2 pi into 5, which is 10 centimeter square per second. So it will be 10 centimeter square. So 10 pi centimeter square per second. Okay. Then, so if it is told that one more example we can solve, that suppose the total cost C of x in rupees, associated with the production of x units of an item, associated with the production of x units of an item, is given by is given by C of x, that is equal to 0.005 x square, x cube, sorry, x cube minus 0.02 x square plus 30x plus 5000. Suppose this has been given. So C of x is the cost as a function of x, where x is the units of an item which is being produced. Then it is asked to find the marginal cost. Find the marginal cost. Marginal cost means we have to find the rate of change of cost with respect to the number of items. It means we have to find dc by dx. That we have to find when 3 units are produced. When 3 units are produced, it means that we have to find the value of dc by dx when x is equal to 3. That we have to find. So marginal cost, it means the instantaneous rate of change of total cost at any level of output. The instantaneous is called the instantaneous rate of change of cost, rate of change of the total cost with respect to the number of items, produced at any level of output. It means at any value of the number of items produced. So here, so dc by dx, that will be d by dx of this 0.005 x cube minus 0.02 x square plus 30x plus 5000. So that will be equal to 3 5s are 15. So it will be 0.015 x square minus this will be 0.04x plus 30. So this much cost, this much rupees per item. You can say. So therefore, this is your marginal cost, MC. So therefore, when x equal to 3, then the marginal cost dc by dx at x equal to 3, that will be equal to rupees 0.015 into 3 square minus 0.04 into 3 plus 30. So it is rupees 30 plus 15 9s, it is 135. So it is 0.135 minus 0.12. So that will be equal to rupees 30.015. Sorry, 30.013. 30.015, sorry. 30.015, which is approximately 30.02 rupees. So this is the required marginal cost per item when the number of items sold is the number of items produced is 3 units. So this is the final answer. So hope you've understood the concepts. Thank you.